Well, good morning, everyone. It's Rob Eisses here from Simba Technologies, VP Sales and Marketing, and we're going to be starting our webinar here in a second. I wanted to also introduce Kyle Porter, our sales engineer, who is going to be joining me and doing some of the demonstrations on our technology and solutions.
Good morning, everyone.
So today the topic is enabling analytics on big data, and what we're really trying to show is how Simba is involved in the big data community by providing really the core technology to connect the various data sources to various BI applications. So we're going to run you through a little bit of introduction of Simba, who we are, a couple of demos, and then off to some Q&A at the end. Just from a housekeeping perspective, a couple of things. We'll have Q&A at the end, but if you want to actually pose a question, please use the chat forum on the webinar. And also, this session will be recorded and will be available on the website later, so anybody that wants to see it or share it, please do. Happy to. And if you have any other questions after that, you can always contact us after this session. So what are we going to learn today? So what we want to really, again, show everybody is how to support any of those data sources that you're trying to connect to in the big data space, and really any data source, whether it's traditional relational stuff or NoSQL solutions, or even more advanced multidimensional stuff, how you can connect and how you use our technology to connect to things like Excel, Tableau, QuickView, MicroStrategy, all the different BI tools out there in various ways. And the other thing that we have is how we're exposing, what we want to show you is how to expose those unique data sources using our solutions. So right through from truly unstructured data in the NoSQL world, right through to multidimensional data, we have tools and solutions that people can use from a do-it-yourself perspective to help them build their own, or you can use our off-the-shelf products as well. And finally, I'm going to talk a little bit about why partner with Simba in terms of our history, and where we are in the market, and where we see the market going, and why we think as the big data world sort of expands, there's more and more need to improve your connectivity to these sources, and Simba can help with that. Okay, just a little bit of the Simba background for those that may or may not know. We've been around for quite a while, since '91, based here in beautiful Vancouver, British Columbia. And really, we have established ourselves as a leader in data access and analytics. And what we mean by that is really we've developed core technology and have enhanced core technology over the years since our original co-development of the ODBC spec with Microsoft back in the early days. We continually sort of have evolved our platform to support the variations of ODBC as it is developed. And we also spearheaded a lot of activity in the XMLA activity area for the OLAP world, and chaired the councils there and did some development work in that as well. And subsequent to that, after those sort of developments, once the big data sort of push came and people started talking about sort of big data and NoSQL and so on, we saw the need for taking that unstructured data and adding some structure to it so that you could actually use your legacy BI tools, anything from Excel again into the other tools, Crystal reports and so on, to connect. There's going to be a need to connect all that data to some BI tool to make some intelligence out of it. So we were the first to launch some big data drivers back in 2012, and subsequent to that have really done a good job in providing this to most of the customers out there, at least the data source providers in the big data space. So this is a list of some of our customers. Anybody from our traditional sort of data source vendors in terms of the Microsoft, Oracles, and SAPs of the world, where a lot of our technology is embedded, right through to the latest and greatest sort of cloud big data sources like MapR, DataStax, Hortonworks. All of those customers use our technology in their stacks. And then we also do quite a bit of work with other folks in the either analytics, the actual visualization world, and a lot of enterprises that use our toolkits to build custom drivers and connectors from their various disparate data sources to their applications. And those could be privately developed applications, or they could be going to more commercial applications. But at the end of the day, what we provide is the glue logic that brings a lot of these customers together. And hopefully that's what you're going to learn today in terms of how we do that, and again, why you should work with us on it. Specifically in big data, and I think this is a very relevant point here, obviously, in terms of where we fit in this world, is we are really have captured the market for ODBC connectivity in the Hadoop and NoSQL world. We're sort of the de facto standard, working with all the major distributions, including Hortonworks, MapFar, Cloudera, Microsoft's HD Insight products, Intel's recent release, Google BigQuery, and so on. And we've also worked on things like MongoDB and Cassandra's solution to actually have, again, ODBC connectivity into that NoSQL world, right? We also work with a lot of the partners at the top end, or the BI world, to make sure that our connectors are optimized for use with their products. We do a lot of work on both sides of the house, whether you're a data source vendor looking up and to connect to different applications, or you're a BI tool vendor looking down into the data source. We can help you from both sides. We're not only limited to big data players, we also do a lot of work in the cloud as well. So lighting up basically cloud-based data sources such as Salesforce and others to provide access from Salesforce data, for instance, up to your BI tools as well. So we have a suite of products there, and we work with a lot of people that are deploying in the cloud from SaaS-type operations and so on. So the key here is that we're not limited to a particular type of deployment. We have a lot of flexibility in the engine to basically access your data wherever it is, anytime, anywhere. And again, this is sort of our view of the landscape in terms of where we fit and why we're relevant. So at the bottom side, you'll see the sort of data complexity, right? On the left-hand side, you have the unstructured data. That could be as simple as sort of base files and very simple things, right through to OLAP multidimensional data sources. So we have solutions that span the horizon from the unstructured right through to the multidimensional, and provide that connectivity in the middle to provide that sort of connection to whatever BI tool or application you want to do. And the key that we do is we provide it based on standards-based, robust, very reliable connections to make those connections work. So instead of doing a proprietary API from one data source to one application, which you can do, the management of that becomes very difficult. So by providing a standardized connectivity methodology, you don't have to do something specific for every application. If you're a data source vendor, you can do one nice ODBC driver via us and talk to everybody seamlessly. So it's all about seamless, robust, reliable communication between those two pieces. And the problem that we're really solving from a connectivity perspective is generally connectivity is hard. Everybody focuses on the application and the knowledge you're going to bring out of that application, or the analytics or the visualizations and so on. But you have to make that connection to the data. And if your data is somewhat unstructured or different, you have to put it in a format that makes it usable for that application to take advantage of it, so that you can provide that knowledge to the business user that is looking to do something. So unstructured data, right, needs structure at the end of the day. Schemaless is great, from a concept to say, well, I can take all this data and have it reside in my database, but by itself it's kind of useless, right? So we need to add some functionality to that, or some structure to it, to be able to report on it and actually take advantage of the legacy applications that are existing in most of the enterprise out there, and then tap into that data, right? It's even interesting, the term NoSQL is, we were at a NoSQL Now conference back in August, and now the message is, it's not called NoSQL anymore, it's really not only SQL. So people are realizing that, and the movement in the whole big data space is really adding SQL capabilities or SQL type capabilities to that data source, so that you can do actually better analytics and such on it. And what we work with is, we work with a lot of ISVs, or independent software vendors, that are building applications, building data sources that need to talk to these applications, right? We want you, the data source vendor, the ISV, to focus on your core competence and your value proposition, right? Which is not about the connectivity. You can leave that to us. We're the experts in that. We can make that happen without you having to worry about it. And we do it very cost effectively as well. So what I'm going to turn it over to now, I'm going to turn it over to Kyle and talk about a little bit about some of the data sources that we do support, And then he's going to walk you through a couple of demonstrations on different systems that we do, right from a MongoDB type NoSQL scenario to more of an MDX on Impala scenario. So I'll hand it over to Kyle.
Thanks, Rob. So when you're working with data connectors, data providers, ODBO providers, traditionally you have your data source at the bottom. And this can be a disparate set of data. You know, you can have a flat file, you can have an API, you can have web services. And the tough part of any driver is mapping that to the format that the standard expects. So if you're talking ODBC, you'd be talking about SQL in the traditional relational model. If you're talking ODBO and MDX, you're talking the traditional cube model, which you would access through pivot tables in Excel, for example. So I'm going to show you an MDX provider, so an ODBO provider, using Excel on Hadoop, and specifically on Impala. So we have Excel 2010. Just going to go open up the data wizard here. We'll go to Other. We'll go to our other OLAP connector. This is a provider that we've built. And it's based on a rollup solution. So it uses an ODBC connection into Impala, which we've also built. So we'll go and pick. This is just the traditional food mart catalog, which most everyone is familiar with. Test that guy out. Good. And so this is connecting live to an Impala cluster. There's no tricks going on here. So let's pick the sales and employees cube. Okay. So we can see over here we have all of our measures. We have our dimensions and hierarchies that we can expand. So I'm just going to do a simple little report here. I'm not an Excel wizard. I'm not going to make super pretty looking reports. So we'll just find stores and time. See, that came out. You see that we have server-side formatting. I didn't tell Excel that this was a dollar amount. This was picked up by our provider and supplied to Excel. So you can apply server-side formatting and make your reports have a default formatting, which simplifies everything. So we can drill down into Mexico, drill down into 1998. And we can see that the state of Jalisco is kind of underperforming compared to the other states. And you can drill down further if you'd like. It's kind of the traditional PowerPoint, or sorry, not PowerPoint, traditional pivot table experience. And it's all just seamless, it all just works. And so some of you are probably saying, well, Impala is a relational model. So how are you guys getting a multidimensional provider with pivot table support and MDX support on that relational model? And so that's kind of where our secret sauce is. We have an MDX engine which understands MDX and parses that and executes it. And then we map that to the relational model. And we do that through something called our business intelligence workbench. And this allows you to define the hierarchies, the dimensions, the measures on the relational model. So you can see that we have the dimensions here. You can see that we have the stores, which I was using before, with all of the levels. If we pick, say, the store, we can see how it's mapped, which table, which caption column, which sort column is there. If we go to our measure groups, go to our sales employees cube, you can see we have a calculated measure called profit, which we're also using, and how that's defined, the format string that is there, which cube. So you can essentially set up your cubes and map that however you'd like. And so that kind of shows how you're mapping this relational model over to the multidimensional side, and how we've then provided that pivot table experience on top of that. So that's kind of a traditional relational model. Impala provides, you know, your tables and whatnot. What happens if you have something like Mongo? For those of you who don't know, Mongo organizes this data in collections. In each collection, there are documents. A document is essentially just a JSON string with different fields. Here's an example right here of a JSON document. And each document in a collection doesn't have to look like any other document in that collection. So you can add fields, or you can subtract fields. So there's no schema. It's schemaless, if you've heard that term before. So the way we deal with that in our driver is if we take this example here, we have a JSON document. There's one field here called phone with a value. There's another one called contact, and that has a nested document in it called address, and that has a nested document with street and city. So our driver will look at this, and it will dynamically break that down and supply 3 columns. And those columns will be a contact.address.street, so contact, address, street, and that'll have a value of 123 Broadway. Similarly, we'll also have the city, which has Vancouver for here, and we'll also have one called phone for our other field. So that's kind of a simple breakdown. So what if you have 2 documents and they don't look the same? So that's this second little example here. So we have the same document as in our first example. We also have another document, but is missing the third nested document. And instead, we just have a value. So if we encounter something like that, what does our driver do? And in this case, we'll just break it down into 2 columns. We'll have contact.address, because that's where the similarities are in the 2 documents we have. And then we're just going to report that as a string type. So we'll report 22 Canby Vancouver as one value, and then we'll actually report the JSON string as the other value. And this is because we couldn't break it down further into another nested document. For phone, we have phones in both documents, so we'll be able to report both of those. So it's kind of hard to see in static examples, so we also have a demo of what this actually looks like. So I have Mongo running on my machine right here. And we can go and do the Mongo shell. We have a couple of databases set up, one of which is the TBCH database, which is the Transaction Processing Performance Council data set. So we'll just use that data set. There's a couple of collections that are defined here: customers, orders, parts, suppliers, Mongo collection indexes, and then also this special metadata collection. I'll explain about that one in a second. But for now, let's just look at the orders collection. So I'm just going to return the first document in that collection. So that kind of looks like a big mess of text. But I've taken it and I've copied it and I've formatted it a little bit nicer. So we can see there's a couple of fields: the ID, customer name, status, with the associated values. There's a date. There's also this line item field, and this is an array. If you don't know what an array is, it's essentially just a list of items. And each element in that list is another nested document with other items. So how does our driver deal with this? So here I have our configuration dialog for the driver, and we have this schema definition tool within this. So if we open this up, we can see all of our collections that I showed in the Mongo shell. So we'll pick orders, and we can see at the top, this is a list of all of the columns that our drivers found by inspecting the data. And we can scroll through and just check out the types, the source type, the source name, what name we want to call it. And we can alter these. So if you don't think that this is going to be a string and the driver thought it was a string, you can change it to another different type. At the very bottom, we have what you'd actually see if you were to query that table through SQL. You can see we have our ID. So if we look at this example document that I pulled out, ID of 1, customer name of 36901, and you can see that this is mirrored here. And then our arrays go over. So if an element is not in a document, but it is in another document and we have a column, we'll just stub in null values there. And if you don't like the way that the drivers created this automatic mapping, you can go and you can add, remove columns, you can show or hide them, and you can kind of modify that mapping as you see fit. So let's go save this. So what does that actually look like when you're using it? So we can just run this through Tableau. So we'll connect to some data. We'll go with the generic ODBC. We'll select my MongoDB. connection. So we can look at single tables. We can do multiple table joins. Kind of one of the more interesting things is that we can do custom SQL. So our driver provides full SQL capabilities on Mongo. So we can just issue a standard ANSI SQL query, and that will automatically break it down and call the correct functions and APIs into Mongo to get that data back. And it's all seamless. You never notice anything. So we'll just do a simple query here. We'll just select the supplier's name, supplier parts brand, and cost. We'll do an inner join, and we'll just limit it to 10,000 rows for now. We can preview the results. And so this just issued that SQL query to the driver. It broke it down, and then it queried Mongo in the background. So we can see the results are coming back. We'll go OK. And normally when you're connecting to something from Tableau, you would pull that data into Tableau and blend it here, and blend it in Tableau. But with our driver, you don't have to. You can leave all of your data in your big data source. So we can leave it in Tableau, and we can work on it there. So we can see that our columns and our measures showed up correctly. Well, experts in you guys can make a really nice, formatted, amazing-looking report.
The other thing to note, Kyle, just on that, we're doing a demonstration in Tableau, but it really, because this is a standard ODBC driver, any application, ClickView or others that support ODBC, you'll get basically the same sort of operation, correct?
Exactly. You can use Excel. Anything which supports ODBC, you can use the drivers, and they will work exactly the same way. We're just showing Tableau here because it looks pretty, essentially. So you can see that we have our values showing up here. So we have our brands across the top, suppliers, and then the actual cost for a specific brand for each supplier. And it's kind of hard to see what's going on here, so we can use heat map. We'll just switch this around here. Kind of makes it a little bit clearer. So for each brand, we can go down and we can see, for brand 15, you really don't want to buy it from supplier 2 because they're going to rip you off. But you probably want to buy it from supplier 17 because they're really cheap. And so this query was dynamically issued against MongoDB in standard SQL, and our ODBC driver and our SQL engine broke that down and mapped that to the MongoDB data source. And this can be applied to any data source. So we have other big data drivers against Cassandra and HBase. Pretty much any model that you have, we can map that to the relational model, and you can connect that data source to something like Tableau or Excel, like I've shown here.
So I think one of the big benefits here again is twofold. One is real-time connectivity from your BI tool of choice to that Mongo data source via ODBC, and the other thing is it's a standards type model whereby it you don't need a specific proprietary API to make that call, but your users, your business users, can be using multiple different tools and still access that same MongoDB database, for instance, or any other database the same way. So from a support perspective, from a multi-user support perspective, going with the ODBC connection really makes a nice seamless connection for your users. So hopefully those two demonstrations gave you a sense of sort of how by using Simba tools you can connect from some of the various data sources to the different applications. I'm going to walk you through a little bit about sort of how we operate and some of the solutions that we have today as well, and sort of how, again, whether you're an enterprise, whether you're an ISV, whether you're a data source vendor, how you can deal with us and work with us, right? So we really focus at working with other businesses to help them sell more of their solutions. So ISV, application developers, enterprise customers, so on. And we really deliver it three-way. We have what we call our commercial off-the-shelf or our ready-to-use products, which are downloadable drivers off our website and for things like our MDX for OLAP connectors, for things like Oracle OLAP. We have our big data drivers that for MongoDB, for Cassandra, for Salesforce, for Hive, for HBase, and so on, and Google BigQuery. Then we have our embedded OEM programs, which what a lot of customers have done is taken our off-the-shelf products and just licensed them and branded them their own and distribute them through their distribution to their customers. So if you have an application or a need to say, I want to take your driver, package it as part of my product and give it to my customers. That's what our OEM white label program is all about. And then finally at the bottom what we have is our do-it-yourself or our SDK program. So those are really designed under two different profiles, and I'll talk about sort of what those are under two different products, the Simba Provider and the Simba Engine SDKs. And what those allow you to do is actually take our core engine, which is the same engine that we use internally to develop all our big data drivers, and actually use it to customize your own driver for your own data source or application. So a very flexible sort of kit that allows you to, available under very flexible licensing terms, to actually go and build your own driver, right? What do we have for solutions today? So I mentioned some of the ones that we have, the Hive, HBase, Mongo, and so on, and below those are some of the customers that we have. So we talked about it before in terms of the big data players, in terms of where we fit and why we consider ourselves a de facto standard there. We really have all the major distributions for Hive using the standard Simba ODBC driver in their solutions today. And so you can get them from them, or if you're doing a full open source program where you've got a full Apache Hive or Hadoop implementation, you can also get the driver directly from us under a direct license. So different ways to work with us. We do have products all the way down the stack in the big data space, and we're looking for and doing more all the time with things, other NoSQL sources that are coming live, or we partner with some of the other NoSQL players, and they have custom stuff that's done directly that uses our technology, but it's under their brand. And then at the bottom we have sort of our MDX providers. So we've been in the OLAP world for a while, and I'll talk about that in a second, providing core technology to companies like SAP, Teradata, and so on. And again, we showed last year our MDX on Impala in a demonstration last year at Strata in San Jose, and we're looking to commercialize that and get that to market quickly with Cloudera in the near future. So some interesting stuff there. In terms of just getting back to sort of what do we support and how we support it. So from an architecture and deployment perspective, we really are flexible in terms of what our engine can do and where it can be deployed. So whether you're a SaaS provider, whether you're a private cloud, whether you're doing a full in-house type of implementation, we can support through our driver and through our stack really any sort of version. Client, client-server, cloud, on-prem, off-prem, doesn't really matter. And really on any data source. We haven't really found data sources that we can't deal with. Again, it's just a matter of how much work it is to turn it on. But a lot of them, the more we have, and we'll get into sort of the nuts and bolts of the engine in terms of why we say that and why we can do that in a second here. Okay. And really comes down to our secret sauce, or what we like to call our secret sauce. And we have actually two versions of it. One is our Simba engine 9.2, which we just released our updated version of the Simba engine just this week. And it is our relational driver toolkit. So this is what all our big data drivers are built off of. It includes a full SQL engine. It has a very flexible, what we call a data source interface, and I'm going to let Kyle talk a little bit more about that. But it also allows you to, and it has basic components for about 90% of most of the drivers that we ship today. And then the customizable pieces are this flexible DFI, which I talked about, which is sort of what you can customize. So what that allows you to do is actually build a driver, a custom driver, and have a prototype working in literally 5 days. In the kit itself, it actually has multiple sort of sample versions of drivers that you can take and then rip apart and customize to your own liking. So very effective sort of work with, very cost effective to license for OEMs, and a very powerful tool, right? I'm just going to show you this slide. It's a bit of an eye chart. And again, all this information is available on our website. Please, look at it and ping us if you have any questions on it. But I'm going to let Kyle just talk about some of the core sort of functions of it from our Simba engine, our SQL engine, as well as our DFI interface, which are two sort of key points, right?
Sure. So as I mentioned earlier, we have our full Simba SQL engine, which is a full ANSI 92 SQL engine. It includes something called collaborative query execution. So our SQL engine can do everything you'd expect it can do. It can do unions, joins, aggregations, filters, all the good stuff. But if your data source is amazing at doing aggregations, you can do sums in split seconds on billions of rows. we can actually pass that operation over to your data source, and you will handle that, and our SQL engine won't. So we can kind of integrate with your secret sauce and your data source, and that makes it really powerful. So we collaborate on execution with you. The data store interface is our collection of classes and interface, which is kind of the barrier between the custom bits that you're going to write for your data source. You know, how do I connect to your data source? What does the metadata look like? How do I retrieve this data type from your data source? And that's where all those custom bits go. And that kind of maps that custom bit to our standard format with our SQL engine can then work with. Or if you already have SQL capability, you don't need to use our SQL engine. And then that will be passed upwards in the diagram to the communication layer, and then through the ODBC, the JDBC, the ADO.NET or OLADB component, and then up to whatever application you're using. The communication layer is kind of a black box which encompasses our client-server architecture if you need it. If you don't need to use it. But if you do, it gives you a really powerful way of putting your data in the cloud if you need to, or if you have a powerful server, you can have just a light client-side install, and it will use our custom wire protocol, high-performance wire protocol, to speak to the server. And one other nice thing that the communication layer gets you is that you can write one data store interface using our client-server architecture, and you get ODBC, you get JDBC, and you get ADO.NET all in one. So all those clients will talk to that same server. And those clients can be of any business, and those clients can be on any platform that we support, talking to a server of any business on any platform we support. So it really reduces your testing workload.
Great. Thanks, Kyle. And, you know, on multi-platform support, as Kyle mentioned, right, I mean, standard, obviously, Windows, Linux, and some of the old traditional AX, HPUX, and so on. And also Mac support, which is becoming more and more important out there. And the Simba Engine 9.2 is actually the only commercial one that supports Mac OS as an OS as well. So again, full flexibility across the full stack, across full OSs, and a really powerful tool to get you going. These are just more of the other feature sets that we have on that. As mentioned, we just released our Simba Engine 9.2 kit with enhanced security support, which is becoming more and more important, especially in the big data space, with full Kerberos support and also enhanced index support. So those are a couple of the features that we have new. If you want to learn more, just by all means jump on the website, and all the documentation is on there for that. Right? Besides that, again, all the different localization, different OS support, the collaborative query execution, which Kyle mentioned is a very powerful tool, and the wide OS support. So, again, more features on the website. Secondly, we have, what I mentioned was, we have two different flavors of our SDKs. This is our Simba Provider SDK, which is really our multi-dimensional provider toolkit. Right? So this is, if you're familiar with terms like OLAP, MDX, ODBO, XMLA, and that sort of space, this is the toolkit that allows you to build connectors for multi-dimensional data sources. The technology in this is used by literally over 50% of the OLAP solutions in the market today, including what's included in SAP and their HANA product. We work with Oracle OLAP solutions, Teradata's OLAP connector, Cognitio and Exasol are two recent partners more in the big data space that also use our core technology for their cube builders inside. So again, a very powerful tool, and it is a foundation that's providing us the flexibility to do MDX on Impala, right, which was the first for Hadoop that we announced. And we're moving more on that, and we're going to do more different MDX sort of solutions on different versions of and different implementations in the Hadoop world as well. Okay. And where are we going on this? What does this all lead to, and what does this mean? Well, from a big data perspective, obviously big data is the flavor of the day in terms of databases and sort of where people are moving. What we've seen over the last couple of years is, while the interest level of big data has grown dramatically, some of the shortcomings of it thus far have been, well, I got all this great data, now what am I going to do with it? How am I going to visualize it? How am I going to look at it? How am I going to drive intelligence from that? We see that as becoming more and more of an issue all the time. Integration is the issue in terms of how do you look at that data, how do you structure it, and how do you access your legacy applications, whether it's crisp reports, Excel, Tableau, et cetera, and make more and drive more intelligence from that, right? We see a lot of movement in the, again, the NoSQL Hadoop world to add more SQL functionality to that, their standard data sources. There's just recent announcements from Facebook even, and their announcement of their Presto solution, which is adding, again, a full SQL sort of enablement on top of the big data world. We're actively doing work with all the different Apache projects in terms of Hive, the Impala, Stinger, Grill, others. Basically, as the world changes and adopts or sees the need to add some more SQL functionality to be able to tap into that legacy world, we're there right beside it. So better analytics, better intelligence from that big data is the next big thing in our mind, and Simba is really the partner to help you get there, right? So in summary, where do we fit and what is our plan going forward? We are really the expert leaders in data access and analytics, and we've proven that through our direct OEM partnerships with many of the biggest players out there. We're thought leaders in terms of developing and understanding sort of the NoSQL world and the schemaless world and trying to add some value to that. And as we evolve our products, you're going to see more and more sort of solutions that are enhanced. For instance, Mongo is a good example. We showed sort of our first version of our Mongo driver that we've built so far. We're continually looking at different ways to expose and access that data in better ways, to take advantage of really the power of what Mongo provides and link that back to the traditional world in a better way, right? So we're continually doing work like that and looking to the community to come and work with us and give us your needs so we can actually help tailor them so that they're actually in a solution. So what we want to be for customers and partners is really your partner, your connection team behind the scenes, right? Again, we work with a lot of OEMs as OEM partners. We're not labeled as a Simba-provided connector in their stack, but we work with them very closely to make sure that whatever their power is in their data source is being exposed to that application so that it can be the most robust, powerful connection possible. Best-of-class, awesome customer experiences, those are the things that we kind of strive to provide, and really look forward to working with any and all of you in terms of providing that connection. Right? I'm just going to open up the questions if there are any from the field. It looks like we have a couple, which is basically there's a question on how do you support sort of cloud sources, or can we explain sort of our client-server deployment model? So I'm going to hand that over to Kyle and just give a little bit more detail on that.
Sure. So it really depends on how your data source is architected. If you consider something like a web service, we can build into the DSI components to access those web services, so you can build out your data source in the cloud in that way. Or you can build out a REST API, and we can talk to that REST API and map that into the SQL calls that applications make. Another option is that I mentioned the client-server components. So you can install a server in the cloud on Amazon Web Service and have our server deployed there. And then you can use our client components, install those on whatever machine that your applications happen to be running on, and have the client components speak to the server that exists in the cloud. And there are other deployments that we could think of, whatever really fits your requirements. The SDK is flexible enough to match those requirements and just be deployed in whatever configuration you see fit.
Great, thanks, Kyle. Another question in terms of, is there a limit to the types of NoSQL data that you can support with the engine? I'm going to leave that to Kyle as well.
So the simple answer is no. The more in-depth answer is that it really depends on how we can map the data source to the relational world or the multidimensional world. So as long as we can figure out a way to do that, we can provide that driver or data access to that. So in the demo, I showed Impala with MDX, and I showed how we did the mapping using that business intelligence workbench application, which mapped a cube onto the relational model. And then in Mongo, It showed how our driver maps columns and rows into documents where there is no set schema already. And we can apply those techniques to pretty much any data source. One of the samples that ships in the Simba engine SDK is a sample which just reads from plain text files. So it shows flexibility in that we can access web services, we can access REST, we can access schema-less databases. Anything you can think of, we can do.
Great. One other check question is, when is the MDX Impala for Impala available? And what I'm going to answer that one, and that's really we're working closely with Cloudera on that because Cloudera is sort of managing the Impala project and doing continuous tweaking and tuning to make that happen. So we hope to see something in the coming months, and we will definitely keep you posted and also post it from Cloudera. I just wondered if there's any sort of live information. Maybe we can now can you open up the mics and see